Hi everyone, this is our website MyMedtro. MyMedtro helps connect people with doctors and auxiliary healthcare services by providing them with convenient transportation routes to these locations. My name is Divya Manahar, and I worked on the back end and collecting and parsing data.
My name's Saad, and I worked on deployment and the API design and implementation.
My name is Maha, and I primarily worked on building the front end.
My name is Duncan. I primarily worked on building tool chains and deployment.
My name is Kyle, and I worked on testing the different APIs.
The three models that we used for our website are doctors, auxiliary services, and transit routes. For the doctors model, we pulled data from the NPI Registry API and got information about each healthcare provider's national provider identifier number, their name, gender, address, phone number and fax number, and specialties about the doctor. For our auxiliary services model, we pulled data from the data.medicare API and got information about each service's name, product, address, and phone number. Finally, for the transit route instance, we got data from the developer.here routing API and got information about each transit route's origin, destination, city, arrival and departure times, mode, and agency or website information if it was applicable. For both doctors and auxiliary services, we collected and parsed data from major cities in Texas and persisted the data to a Postgres database. However, for the transit route data, we are providing real-time data using the Transit API in order to show more accurate and up-to-date routing information. Some additional APIs that we used include the Google Geocoding API, which converts addresses of doctors and auxiliary services into longitude and latitude coordinates to calculate transit routes. Another API that we used is the Google Street View Static API, which allows us to display images of our doctors and auxiliary services with their addresses. Finally, we use the Google Maps React API, which provides a Google map of the locations of doctors and auxiliary services.
So in order to get the data from these APIs, we used the Python's request library. Once the data was cleaned, we stored it in a Postgres database through AWS. We built schemas in our database for each model. We also used Flask and Flask RESTless to build our backend and serve our data to our customers and our front end. Here's an API response. Now this is the doctor's endpoint, and it is paginated, and you can see that there's 10 doctors available here. Using the back populates option in our schemas, we were able to serve information that showed connections to our other models. So for example, we have a connection right here to the doctor location, which is part of the location table. We also deployed our site using AWS and Docker.
Our front end consumed our back end, and we used Material UI and React Bootstrap as CSS frameworks to display our data. We also used React Router to support a multi-page site and navigation between those pages. We used Algolia to implement sorting, filtering, and searching on our model pages. We wrote scripts to move our data to the Algolia servers, and Algolia allowed us to create various indices to organize our data in different ways. On the front end, we created forms to obtain from the user what to search for, filter by, and sort by. With this information, we could choose which Algolia index to use to display our data. We also implemented backwards sorting in a similar way. We also allow for site-wide searching. We did this by creating an Algolia index that contains all of our doctors, transit routes, and auxiliary services. From the homepage, you can search using a variety of key terms related to any of the three models. We also implemented comparison. When the checkboxes on a model page are clicked, we internally add the selected models to a list. When the compare button is pressed, we display only the selected models from that list to allow users ease of comparing various instances.
For API testing, we use Postman to create tests to first ensure that we successfully hit each API request, and then followed that by making sure that we had the correct information returned from those requests.
To test the backend, we use a combination of Python's request library and unit testing to tie each test together. For testing the front end, we use a framework called Jest, which, as opposed to Mocha, doesn't really come with any baggage regarding dependency issues. This allowed us to easily design tests that inspected every single component of our actual React objects, which would then be rendered into HTML. And then finally, for testing the user experience, we use the Selenium WebDriver, which basically runs a Firefox browser without the GUI, as well as the Python unit test framework to tie all together to catch elements and see if everything was rendering on the client end properly.
For our visualizations, we used Recharts, a React library. We have two visualizations for our doctor model. The first visualization is the gender of doctors by city. And as you can see, San Antonio has a lot of male doctors. And then Austin has more female doctors than male doctors. Our second visualization is the count of CVSs by city. And you can see we also added hovering, so you can hover over the chart and get more information about it. So for example, San Antonio has 18 CVSs. Finally, we have a count for the doctor specialties. You have internal medicine at 31 doctors. For our provider visualization, we have 5 visualizations. The first one is the number of politicians per party. Second one is the different offices the politicians are running for. Third one is, as a line graph, the total voter turnout over the years in millions, party counts over the years, and then finally, the number of Democrat and Republican districts. I think the really coolest one is the voter turnout over the years. It's really increased from 2016 to 2020.
To start things off with our group's self-critique, one thing that we did well as a group was being consistent and having high quality communication between us. We held weekly Zoom meetings to discuss what tasks needed to be done and when they needed to be finished, and also used Slack for communicating in between those meetings. We learned as a group to divide up the tasks amongst ourselves based on our individual strengths and specialties, whether that be front end, back end, etc. We also learned how to work together as a team without being able to meet and have face-to-face communication with each other.
As for what we could do better, it would have been beneficial to have better time management and complete things a little bit earlier. This would have allowed us to deal with any last-second problems that popped up, such as deploying or getting the favicon to work. We also wish we had switched roles a little bit more so that we could work in areas that we were less comfortable with.
When thinking about what effect the peer reviews had, I think they encouraged us to take an active role in other team members' work and not to be afraid to ask questions to each other. While filling out the reviews, we had to pay attention to how effectively we communicated our progress to each other. So for every phase, we made more and more of a conscious effort to improve the way we worked with each other.
As for what puzzles us, one thing that comes to mind is how we can professionally implement our concept for the website with better data to the extent that it carries a more professional appearance, as we found ourselves being rather limited by the data that we had available for the project. On to provider critique, one thing that comes to mind as to what they did well was their front end. The look of the website is clean and professional, and we were consistently impressed regardless of the changes that they made. Onto the RESTful API, we felt that while good, and it served its purpose, we felt that the responses were a bit bloated in nature, and we thought that they could be split into smaller API calls to save time and space. As for user stories, we were impressed with their ability to implement a lot of the user stories that we had presented to them in ways that we didn't even expect the quality of, such as their news articles. We had requested that they add news articles to their website, and not only did they do that, but they did it in a way that appears professional and would be easy to use for anybody who doesn't have any prior context as to the development of their site. As to what we learned from their website, we learned quite a bit about politicians in Texas, when and where to vote, as well as historical election results. As to what they could do better, we feel that the number one thing is just making a cleaner API, one that's less monolithic in nature. As to what puzzles us about their website, one thing that comes to mind is the quality of their politician photo data. As you can see, Some of these pictures are low resolution, some appear to be home photos, and some politicians don't have any photos at all. We think this is something that could be easily improved with a better data set. As well as their API, as we mentioned before, it puzzles us as to, how complex it is. It was a bit confusing to use.
Thank you for watching our presentation about MyMedtro, and we hope you enjoy using our site.